We're going to talk about what a normal distribution is. So a normal distribution is the name for a very commonly shaped graph that just occurs a lot as data is collected. Mathematicians noticed that this kind of shape kept coming up a lot. And there are a lot of different characteristics to it. So one of them is that the mean is right in the middle because it's symmetric. And it also has this bell shape. So it's symmetric, it's bell-shaped, and because it's symmetric, 50% of the data, picture this is maybe like a dot plot where this is filled in with a whole bunch of dots. Or you can picture this as like a histogram and you have a bunch of bars. So we're just describing the shape of that. 50% of the data is to the left of the mean. The mean just cuts the data right in half, and 50% is to the right. Again, this is just a very common shape that comes up with different data sets. So for example, measuring heights of a population of, say, like males, or you measured heights of females, it would look like the shape would be a normal distribution. A lot of times when you're measuring weights, a lot of things in science or biology, if you're measuring temperatures, it oftentimes resembles a normal distribution. Also, SAT scores or a lot of standardized test scores. So this distribution just comes up a lot. We use it a lot in math. We're going to look at an example. So the distribution of weights of 9-ounce bags of a particular brand of potato chips is approximately normally distributed with a mean of 9.12 ounces and a standard deviation of 0.05 ounces. So it says to sketch the distribution. I'm going to start with that. It says it's normally distributed, so I'm going to go ahead and draw a normal distribution. So this is the shape of a normal distribution. And then it says the mean is 9.12. And the symbol we use for the mean, or symbol we're going to use for the mean, this is a Greek letter. It's called mu. It kind of looks like a U, but it has this extra little tail in the front, and it's a mu. So the mean, mu, is 9.12. And then sigma, that represents the standard deviation, that's another Greek letter, is 0.05 ounces. So it says we want to labeling the mean. So I'm going to put the mean right in the middle, 9.12. And the points 1, 2, and 3 standard deviations away from the mean. So if we count 1, 2, and 3 standard deviations away from the mean, we're going to label what those values are. So 1 standard deviation is 0.05. If we're going 0.05 ounces away from 9.12, 9.12 plus 0.05, we get 9.17. We're also going to go to the left, so not just to the right. It says away from the mean, to the left and the right. So I'm going to go to the left, down 1 standard deviation. So I'm going to subtract 1 standard deviation from 9.12. So 9.12 minus 0.05, and we get 9.07. So I'm going to go 2 standard deviations away in each direction now. So again, the mean was right here in the middle. In fact, I'm going to label it mu so we know that's the mean. Now I'm going to go 2 standard deviations above the mean. So 1 standard deviation was 9.17. I'm going to add another 0.05, and we get 9.22. And then I'm going to go 3 standard deviations above the mean, add another another 0.05, and we get 9.27. Okay, I'm going to go back down to the left. So I already did 1 standard deviation to the left of the mean, which was 9.07. I'm going to go a second standard deviation to the left of the mean. So I'm going to take away another 0.05, and we get 9.02. And I'm going to go down another standard deviation. So now I'm 3 standard deviations below the mean. I'm going to take away another 0.05, and I get 8.97. So that's all we would have to do for a problem like this. We're just sketching what the shape of the distribution looks like. It says it's normally distributed. That's why we're drawing this shape. Sometimes you'll have problems saying, for example, let's say a bag of potato chips was 9.2 0.22 ounces. And you might get a question that says, how many standard deviations away from the mean is this bag of potato chips? Okay, so I just wrote that out. So if we selected a bag that was 9.22 ounces, that would be 2 standard deviations. So that's here. That's 2 standard deviations above the mean. So to answer this question, how many standard deviations from the mean would this bag of potato chips be? 2, I'm going to put sigma for standard deviation, or you can write out standard deviations. So we'll put 2 sigmas above the mean.